Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing exponential functions. This is standard A.9C in the great state of Texas, and we are using item number 15 of the 2017 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So, we have a particular type of cell that doubles in number every hour. So we need to find a function that can represent this at the end of h hours if there are initially 4 of these cells. Well, it doesn't really quite tell us, but hopefully we recognize at least by not only our answer selections, but also just by the description that this is an exponential function. So here's our standard form. Y equals a times b to the x power. And this doubling every hour, that lets you know that we're dealing with an exponent. And so here we have a. So let's define each of these terms because we're going to pull both of these from the word problem to create this function. So this a term is a constant, right? And it is multiple things depending on the context we're dealing with. So if we are looking at interest and we're looking at compound interest and looking at money deposited, that's going to be your principal. In a larger sense, we are simply just talking about a starting point. So what is the initial amount that we are going to be starting with? That's this a. And if we had a graph, we could actually just call it the y-intercept. Now we call it the y-intercept because the y-intercept crosses the y-axis when x equals 0. Well, what happens if we make this x into 0? Well, that would be b to the 0, which would just make b to the 0, anything to the 0 is 1, which means that just kind of takes this whole thing out and just leaves us with a. So if we can find crossing the y-axis, we have our a. Now, this b here is your rate. And it's going to either be a growth rate. If it's getting bigger, it's going to be a decay rate. If it is getting smaller. And that is what is being multiplied to the x power. And this x here is going to be your steps. Typically, they're going to be some kind of time frame. In this case, we have hours. Sometimes it's every day, every year, every month. But it's the steps in between each iteration of this. So, looking at all that information, what do we have? Well, we're looking for the principal, the starting point, the initial amount. We have that right here. Typically, they have to give that to you, unless it's on a graph. If it's a word problem, they're going to have to give that to you. So we can say, and we'll say n rather than y equals 4. Now, all of these have 4. Take a look at C and D, though. C and D, we're adding these, right? And there is no addition in our standard form. We just multiply a times b to the x power. So we can get rid of C, we can get rid of D. Now, the tricky part, if there is a tricky part to this problem, is trying to find this rate. Typically, they have to give that to you, but all they give you is this word doubles. So we need to know that when you double something, that means you multiply by 2. Okay, so then that means our growth rate is going to be 2. And then finally, the h, that's our independent variable. That's taking the place of the x. So every hour, you're going to take that doubling by 2, and you're just going to increase it based on how many hours you have. And so this a is actually a decay rate. It would be cutting in half every hour. We're wanting the growth rate of doubling every hour. So our answer here is B.